Hello, my name is Mike McNair, and I'll be presenting my topic for Fundamentals of Nuclear Engineering. For my topic, I chose recycling nuclear waste. To understand how to recycle nuclear waste, first we need to understand how nuclear energy is produced. Nuclear energy is produced through a process called fission. Fission is essentially when you take a heavy nucleus of an atom and split that atom into two smaller nuclei and several subatomic parts. Fission produces a lot of energy at power plants, and it does this by after splitting the nucleus, it that reaction creates a lot of heat, which boils water, which creates steam, and that steam turns a turbine, which generates electricity. Now, now that we know how nuclear energy is made, how is nuclear waste made? Nuclear waste is essentially the byproducts from this fission reaction, and that is, it comes in the form of alpha and beta particles, and when it splits, it creates those two nuclei, but it also releases the beta and alpha particles, like I said, but also releases neutrons, which some smaller plutonium and uranium nucleuses attach to create different isotopes, which are essentially just different versions of those atoms, just with more neutrons. And these new subatomic particles are highly unstable but can also be reused in nuclear fission reactions. But it's caught up in other waste products. Now, there are three different kinds of nuclear waste. There's low-level waste, intermediate waste, and high-level waste. Low-level waste makes up the bulk of nuclear waste, up to, I believe, 90%. And it is essentially just very low radioactive material that's in things like in equipment used to conduct nuclear reactions, the clothing, so like gloves, visors, stuff that people wear on plant sites, and the actual equipment itself. Intermediate waste is material that has more radiation, but it doesn't give off enough heat to be considered high level, and it's not hot enough to where they need to cool it down before storing. High level waste is, I want to say, only 3% of the actual amount of nuclear waste. And but high level waste is typically what people think of, and it's not the sludge that you see in cartoons. It usually just means spent fuel, which is used fuel rods of uranium and plutonium, and those are typically just come in the form of used fuel rods that are used in nuclear fission. On to the methods of recycling. The most common recycling method is Purex, and Purex basically what it does is it separates the leftover uranium and plutonium from nuclear waste by using liquid to liquid extraction. It does this by using an organic solvent and nitric acid to dissolve waste from the wanted reusable fuel, and then once that waste is taken, it is solidified and you capture the oxides, as you can see from this diagram behind me. I think my camera's a little bit in the way of um, some of the labels, but you can see some of the process behind me. And then you have pyroprocessing, which is one of the second most common um, processes. It's a little bit more complicated. It uses spent fuel that's chopped up into pieces, and that fuel is put in a molten salt bath. And once it's in that molten salt bath, um, people working on the plants essentially electrify that mixture to where it creates a separation between uranium and anthodides, which are just elements on the periodic table from atomic number 83 to 103. Oh no, atomic number 86 to 103. And it separates those elements and products from the other more radioactive waste. And with these newly formed uranium and actinides, you separate them to create new rods and you let them solidify so that they can be used for further reactions. Now on to the benefits and the drawbacks of recycling nuclear waste. For the benefits, we have several. Because we're separating these precious metals from the waste, now you can use even more fuel, which increases the efficiency. But also, since you're taking it from the waste, now you have less volume of waste, so you need less storage, you need less space for storage, and like I said, you can use that fuel for more power to create more efficiency out of your reactions. It also reduces the amount of mining needed to get uranium, because instead of having to dig through the earth to get more uranium, you can just use the uranium that you've already used. Also, you don't need to have as many stockpiles, and you don't need to enrich those stockpiles, since you're just reusing the uranium that you already used in previous reactions. Now there are a few drawbacks. They're not many, but they do have large consequences. The first one doesn't have a large consequence. It's more so just creating the infrastructure. It's very expensive to maintain and gather materials that are needed for recycling nuclear waste, but that can adjust with time. However, the more costly drawbacks are that plutonium extraction increases, and plutonium releases a lot of beta and alpha radiation, which ionizes the surrounding particles and creates them to be radioactive and unstable, and are very deadly for humans. And with the increased extraction of plutonium, it could increase certain countries' reasons for creating nuclear weapons, such as nuclear warheads. But overall, in conclusion, nuclear fission reactors provide a safe and sustainable way forward for recycling fuel as the demand for energy rises, and recycling has its disadvantages, such as the cost, people's public perceptions, and the possible hazards, but the positives outweigh the negatives, with cutting the waste, lowering storage requirements, increasing energy production, and promoting a sustainable future. These are the resources that I use for all the information in this presentation. Thank you for your time.